Hello everybody and welcome to this latest webinar on network automation and mobile mapping, where we'll be presenting this webinar together with Orbit Geospatial Technologies. My name is Jonas Verstijft. I'm Marketing Manager at Comsof, and I'll be presenting today with Lomme de Vriend, CSO Sales and Marketing Executive at Orbit GT. All right, let me give you an overview of what we'll cover in this webinar today. We'll start off with a short introduction on FiberPlanIT by Comsof and Orbit Geospatial Technologies. And then we'll go into more detail on the topic of today, mobile mapping. What is mobile mapping? What can you do with it? And particularly, how can you use it in your FTTx project workflow? We'll end the webinar with a short Q&A session. The webinar today will take around 45 minutes. Please feel free to ask questions via the GoToWebinar Q&A window, which should be located on the right-hand side of your screen. We'll try to treat as many questions as possible at the end. After the webinar, there normally should be a short survey. Please feel free to fill that in. That's very helpful. And later this week, we'll send a link to the recording of the session so that you can rewatch it or share it with your colleagues. All right, so the company I work for is Comsof. We're located in Ghent in Belgium, and we also have an office in Toronto in Canada. And our focus is on planning, design, and automation. We do this under the brand FiberPlanIT, and since 2008, we market this as a software solution. And we also offer network planning and design services. The software has been used in over 200 projects around the world in more than 40 countries. Now I'll let Lomme present his company.
So Orbit GT, we're headquartered in Belgium, in Lokeren, which is quite close to the office of FiberPlanIT in Belgium. We exist since the 60s. It's a family-owned business, but based on the evolution and the possibilities in software that you had at the end of the last century. We got a market which is since 2008 really global. We offer 3D mapping software products, and we distribute that via reseller channels. We have today 58 resellers which are spread globally. And if I'm talking about mobile mapping, we have today in projects and customers that are running Orbit software a real worldwide coverage. So I want to start with explaining what is mobile mapping, because the webinar today is all about mobile mapping, and at least the combination that we have with the products of FiberPlanIT. Now it's really important to understand, of course, what is mobile mapping. So mobile mapping brings the full representation of 3D reality onto the desktop using sensors mounted on a mobile vehicle. It can be a car, a train, a boat, a bike, a UAV, or even a person. So in fact, if we're talking about mobile mapping systems, you can name it as you want. It's onboard systems, it's reality capture systems, but basically these platforms combines a camera and a LiDAR scanner or a LiDAR system. So this combination gives the possibility to map imagery and LiDAR scans, indoor, outdoor, from aerial perspective. In fact, you can bring the outside world onto the desktop or capture, of course, the reality and use it inside the office. So what is the result? The result of mobile mapping, so these platforms that collects this system, is a combination of a picture and a scan. Or of course, each one separately. You have, of course, systems that only scan or only take pictures, or of course have the combination of the two resources. Now, thanks to the fact that these systems are of course combined with a GPS, with an IMU and processing of the data, we get as a final result of each image exact position and orientation of the recording. As well as it is combined with a LiDAR scan, for every pixel in the picture, you get the right XYZ coordinate. So in other words, we have an extreme accurate measurement capabilities that we can use. Now, before showing, in fact, and I'll start already the movie, before we share how we can use that mobile mapping data in a, so before we share how we can fit that mobile mapping project in an FTTx project, I want to share first out of the box a movie about a very nice mobile mapping project in Belgium, where they captured more than 64,000 kilometers of roads 2 times. So it's already covering 2 years. And it's a huge data set that is used by the GIS department in Belgium, by every employee that can use this data. And you see in this movie describing how they can use it, all the data on the field, or the data that comes from the field, how they can use it on their desktop. So they're now describing, in fact, some typical situation, a typical standard situation where they need to decide to put some new works, and they decide that, in fact, on the desktop. So it's a complete database of 360-degree imagery that covers the entire region, and thanks to that, of course, they can make these decisions. It's the right to use is for every employee of the GIS departments in Flanders, and they can use it to make their decisions on any kind of case, which is of course related to works that they need to do, to updates, of course, of streets, to households, and so on. They're explaining here how the pictures are covered. Of course, it's imagery in combination with LiDAR scans. And of course, that gives the possibility to, in a very easy way, in fact, measure on the image. So what can we do with it? As we saw in the movie, we can reduce field trips because you don't need to go on the field to check exactly what you need. Of course, extraction of road infrastructure. So you can also measure, you can update streets. You can do inventory of assets. You can do visual checking and judgment. You can do placement checks if needed. And of course, it goes a little bit further as well. You can evaluate all the data that you already created, evaluate, for instance, trenching options, but also do 3D analysis, and also deliver finally to your customers some support. And these points, we will discuss them in the FTTx project, and what we will explain later on, we will go into some of these nice opportunities you get thanks to mobile mapping data. But before I'm doing this, or before we go over to the FTTx project, before I just want to explain you a little bit more about the relationship then of mobile mapping or the relationship between OrbitGT and mobile mapping. So what is OrbitGT doing in that complete story of mobile mapping? Well, these days, mobile mapping projects are covering complete countries, states, cities all over the world. And what we see today that there are big projects going on in Europe, just to name some, in Belgium, in Sweden, in Austria, in Portugal, and so on. Even also of course, in the United States, in Asia, in the Middle East, everywhere we see big projects where they cover complete countries or complete states. Now, it's of course, it's very important if you see those projects that there are running hundreds of different mobile mapping systems around. So there are systems that are made, of course, manufactured by different providers, hardware providers. It's of course important that that we have a kind of standardization in the way that you can work with this data. So it's of huge importance that any captured 3D data, which comes from different mobile mapping systems, can be used further in the workflow, further in the process. And so far, standardization is the key. And as OrbitGT, we were successful in providing a workflow, providing products that can read all these different systems that are provided by all the different companies in one and the same workflow. So you don't need a black box solution. You don't need one type of software exactly linked to that specific type of hardware. No, you can just read that coming from any kind of existing data, any kind of new data captured with different system, bring that into the Orbit workflow, and then use that data, of course, for updating your project.
All right, thank you, Loma. So what we'll do in this part of the presentation now, we'll go a bit in a bit more detail and see how the mobile mapping data can be used in a FTTx project workflow together with the FiberPlanIT software tools. If we look at the workflow here, what we will look into is a process where we want to build a new fiber network. What we identify as a first step is that you need to gather all of the GIS data that is needed for your design, so the GIS data of your target area. This will feed the high-level design stage where you create the high-level design for your network based on your specified design rules. Of course, this goes hand in hand with a survey where you need to verify the design to make sure that it's feasible and constructible. And then at the final stage before construction, you create your to-build plans that can be used by the field crews so that they know how to construct the network and then document the as-built network in a network inventory solution. So this is the project workflow that we will use throughout the session. And the first stage that we look at is gathering the GIS data that is needed for the design. This GIS data can come from a lot of different sources. You can have base maps, you can have existing GIS or CAD data that you have yourself or that's purchased from a third party. Also, address locations can be provided by the government instances or can be publicly available. You can have existing network data if you're looking to upgrade your network, perhaps from copper network or coax network. You want to upgrade that network to fiber to the node or fiber to the cabinet or fiber to the DP. You can do a field survey as well, walk around in the area to capture all of the data that might not be there or maybe fill missing gaps. And one of the data sources that we want to present today is, of course, mobile mapping data, and Loma will explain this in more detail.
So if we, in that collection step, if we need to add new or update existing GIS data, I have here just two examples to show how and what as additional GIS data we can get from mobile mapping data. So as you already see on the slide, of course, get information about missing buildings, maybe some streets needs correction, maybe a cabinet should be moved, or a cabinet can be used in the network and is not up to date on the data that you received. Addresses, check all the addresses, check also the households, get an estimation of the number of people that are there per household, and also inside and the size of a building, a pole, a street distance, and so on. Just to show you, I have here a view on a nice project which was made in Hollywood in the United States. So what you see here is a typical mobile mapping project. So you see a 360-degree picture where you can turn around. Of course, you can jump from one image to the other image, and you can walk around in the city to check the complete environment. So what needs to be checked? Of course, you see already a lot of cables. And you can, of course, go into detail, check everything, check also the quality, check or if the data is up to date, if it's available or not. But going further, you also see here, if I move onto the crossroad itself, you see here some cabinets. Maybe there are on the spot where they need to be, maybe not. Maybe you can use them. All this information, of course, can be checked and can be updated in your data. As well as if I turn around and I look at the other side, I see here a gas station, so a utility, which is, of course, I mean, if you planning to do some work, at least you should know that your GIS data, or that at least the GIS data is up to date, and that you know where are the entrances to the gas station, where are essential or danger positions or locations that I need to take care of, that I maybe need to update in my database to provide that information. As well as it goes a little bit further, this is mobile mapping data. As I already said, mobile mapping data or 3D mapping data, it's on a platform that can come from any kind of a moving vehicle. That can be a car, but as well that can of course be a drone or can be an airplane. So from the same spot, we have here a oblique picture. So an oblique picture that can switch position from, I just need to open, sorry, I need to open this one right here. That can switch position from a view from the south, a view from the east, all on the same spot, and check in fact if every information I have, is that complete? Do I have information from the backyard? Do I have information from the street view? But combining all those resources and updating your GIS information, and of course add value to the information of your existing GIS or CAD database. Now, a second example is a case here in Flanders that I want to show, and you see here already the difference. This is a lot of GIS data that I have available, which was covered or which was collected by the government itself. Of course, you need to check. I mean, if you start doing your data collection and you need to update all the information, you already see here, for instance, if I show the ortho, that the building which is below this building, which is below the vector data, this is having some kind of a gap in its data. Of course, you can check that, and you can use the mobile mapping data to check if that's accurate. Is that the case? So you just open a view looking to that position. Okay, that's right. That's indeed the right information I have. Next to that, of course, also checking all the attribute information you have right here. So you can, in fact, check if there's a manhole positioned right here, if the poles or indeed, the point features, if these are indeed a light pole right here. So you check all the information. You even can update that information. As I said, you just select the attribute and you can check if that's a building. Okay, right, then you can use it. If not, you can add information. So you see, thanks to the fact that you have a street view in combination with an orthophoto view, you get a lot more information. You don't need to go on the field to check or update your existing data. Even if I go a little bit further in the street and I go back to my mobile mapping, I open a view looking in this direction, I see that right here that this spot is maybe not the exact or a good location to put a box like this. Maybe that's something I need to add to my existing database. Maybe that's something I need to remark or take a note of it. As well, of course, of if I turn around, checking as well all the house numbers and updating that information. So you see a lot of information get out of a street view perspective, next to the fact, of course, that you can use your orthophoto or your oblique data. So back to you, Jonas.
Right, thank you, Lomme. So now we have arrived at the second stage of our project workflow, where we'll look into doing the high-level design using design automation and the combination with the survey. All right, so in this stage, what we want to do is create the high-level design for our target area of the FTTx network. So what we want to do is we want to design a network that is as cost-efficient as possible and which follows a certain set of design rules, like, for example, whether it's a point-to-point or a PON network architecture. There will be design constraints based on the cabinet size or the cluster size for a cabinet that can be used. And what we want to do in this design stage is locate all of the trenching, estimate all of the ducting and the cabling that is needed for connecting all of the homes in our area. And as one of the outputs as well of this stage, we want a detailed bill of material so that we know what the volume of equipment is that we will need to order and what the total price of our project will be. Okay, so to walk you through the steps of the design, of course, we have a target area in mind, and we have good quality GIS data, which can come, as we saw, from different sources and from mobile mapping information. We have detailed GIS data. We have a complete view of all the streets that are in our area. All of the homes are present, so we will know that we will connect everybody. Also, the home count will be updated so that we know exactly how many homes, how many living units there are in each building, so that we make sure that we scale our network accordingly. Now, in the FiberPlanIT Designer, you can load all of this GIS data, and we have some automated tools to make sure that you get a fully connected network. In this case, it's an underground network. So we make sure that we generate all of the possible ways to route the cables. As a second step, like I said, in the design stage, you need to make sure that you design a network that is according to your network architecture. So it is necessary to specify the design rules that need to be followed, like which cables can be used, what is my cabinet size, where do I locate my splitters. And as we want to build a cost-optimized network, we also need information about the equipment and material and labor costs of all of the equipment, so that we can route the most cost-efficient way. Then the software can use this information and then plan the network. So automatically locate cabinet locations and cluster all of the homes together in these and connect them to these cabinet locations, and then route all of the cables, all of the ducts, so that you have a fully connected network. Of course, you need to make sure that this network is feasible, and for this you will need to do a field survey.
Well, of course, field survey is one way to go. I mean, you can go, of course, on the field in person and check the situation. As you already understand, and I guess as you see, of course, mobile mapping data can give you that that position or that information that you don't need to go on the field, and that you can update the design or give the remarks back just by checking all the information that you have. So you can in fact fine-tune your design from the office instead of going on to the field. And if I just give you some examples, what you see right here is we just opened the two positions from the same house, but then into the front and then also the house from the side. And what you can see here is that maybe it should be a much better idea, because you have two entrances, so you still have the choice to put your line close to the house. So you can just choose, instead of doing that from the front, to choose the one from the side, or the other way around. So you see, you get all the information, all your design information, as well as all the information that is saved or stored in your GIS. But you can combine that with a 360 visual view to the house and see where exactly I would put that cable. So you see that here I would advise to do it in the front.
Indeed. So yeah, the survey is essential in the process of the design, to make sure that you create a design which is constructible and which makes sense. And mobile mapping can be used to, in the example that you show, make sure that you have the lead-in in the right location. Well, now all of this information that you the changes that you make to your design with mobile mapping data, this information needs to be fed back into your design, and with FiberPlanIT, you can force these design constraints. So force particular cabinet locations. In the example that was shown earlier, where you had a Dropbox or pedestal which was run over, this might not be a good location to place a cabinet. So these kind of changes you can also make in your design. Also reallocate homes to a different cabinet or impose rights of way constraints. And with the software, you can force these design constraints and then recalculate so that you get a updated design and bill of material. All right, so then we come to the third stage of our FTTx project workflow. That is to create the to-build plans. So from the design which is surveyed, you now need to add all of the details to make sure that the field crew knows how to build the network. Right, and for this, you can use the FiberPlanIT Engineer. And what you can do with FiberPlanIT Engineer is make sure that you create consistent construction plans, all of the splice reports, all of the maps that you need, permit plans that you need for constructing your network, and make sure that you have a unique and consistent labeling of your equipment. So make sure that your cables and ducts get a logical name, that all of the equipment is labeled as a unique label, and also make sure that the splice rules that you have put forward are imposed in the correct way. So with the engineer, you can automate this process and make sure that you create all of your to-build plans in a consistent way, and make sure that you have a connected network.
Well, and in that step of that construction, of course, there's a lot to tell to the people on the field how they maybe need to put a cable, and in that case, I want to show you some live example as well. What is the big value, of course, of mobile mapping data? As I already said in the beginning, you get, of course, a combination of point cloud data and image data. So if I just add here the point cloud data, so you see that these points are lying on top of the image or just behind the image, but at least they give you the possibility to measure onto your image. So for every pixel or every location you have on the image, you get the exact XYZ coordinate, and we will use that to deliver a result, or to provide a result to our teams on the field. So if I give you that example right now, I can just go and measure, and in fact update here. For instance, if I get the example of a cable that needs to put from here, I can just start here right away. I can click here, go to the next position, move a little bit up, maybe zoom in where I exactly need to be, and just end my line right here. So I get this this information. I can just copy that to a feature, which gives me which put that, of course, in a line feature class. But as well, I can make a snapshot of this and deliver that result, maybe with all the attribute information that is needed. So who was the one who created that? What's the creation date? What is the type? What is the size of this cable? What's the length of the item? But at least this can be provided to the team from onto the desktop. And what is the big advantage? What is the key point that we want to stress is that you centralize the decision. So you make sure that the people on the field don't need to make the decision on where a cable on a facade or underground needs to be constructed. You can just decide that and make the decision from the desktop and make sure that you centralize, of course, all the decision and make it in the same way for every case, for every city, for every part in your project.
Okay, so as a final step in the workflow, you of course need to document your network. Document your network in a network inventory solution so that you can use the information later on to activate your customers and operate your network in the best possible way. So it might be that during construction you still make changes to the way that your network is built, changes that were not foreseen in earlier stages, which you need to react to during the construction phase.
Well, and in that particular part of the project, it's of course important that you can not only use mobile mapping data from your own server in your own company and use the data which is close by. This huge amount of data, which covers maybe a complete country or a couple of cities, needs to be available as well for teams on the field. And in that way, Orbit as well has products which is called 3D Mapping Cloud, so a cloud product where people can store all the mobile mapping data and they can share it via all the different platforms that are available in all different ways. So you can, in fact, provide all this information as well to the team on the field, on his tablet, on his phone, or in a web browser on the laptop. And of course, that gives a huge advantage in redlining on the field, as was introduced by Jonas. It's a very easy way of documenting where exactly there is maybe a difference than what was the exact position I needed to put the cable. I mean, you can just change that. You can make remarks. You can in a very easy way, of course, provide that information, because we know all the difficulty, of course, that on the field there are people that the ones are using a tablet, the others are using a laptop, the others are using paperwork. So everyone is using a different way to communicate and tell something which is in fact can be streamlined in one and the same application. And what you see here, so as I already named, 3D Mapping Cloud is the perfect possibility to share all that information, any kind of 3D data, so your mobile mapping data, your aerial data, but also all your vector data can be streamed and can be shared with the people on the field. There's even an API available, so you can even in your existing workflow, you can just share that mobile mapping data so that people can use it as they are used to do in their daily jobs. Just to give you an example, I'll go now to the project that I already introduced in the beginning, the project of Flanders. So you see here, this is a web browser. I just log in via the web browser, so that can be done, of course, on a phone or on your tablet. But you can just search, and you have kind of a geocoding search. So I can, for instance, go to the location of FiberPlanIT. So we go to Dock Noord in Ghent. I can just put the position right here in front of the building. So then you see this is the view they have in their office. And if you need to make a remark on the field, thanks of course to that point cloud and that easy way to click and to measure and to create a line, people on the field don't need to have a huge knowledge on mapping, or they don't need to be a surveyor that needs to handle or deal with a GPS. No, they can just push some buttons, and based on that, they can just create a line. So they say, okay, I started here. I then went up to here. I put the cable right here, and then I ended somewhere here. So that's my line I've created. I just add that to feature class. I maybe give some comment that this was, I don't know, this can be, of course, defined as you want to do in your language, in your set of attributes that needs to be added. And you save that as a line feature, and then of course it's also presented here on the 2D map. But as well, this is saved in the database and can be stored. And of course, the teams which centralize and do all the decisions can use that information to update again the map. So you see, there's a very easy communication of a way how it was constructed, and maybe is different. It's different from the design, but at least you give a very easy way to add information, as I already said, and I just want to stress that point. They don't need to deal with GPS. They don't need to deal with survey equipment. They just can do it with a simple click on a tablet, on a phone, on their laptop, clicking onto the picture and saying exactly where they have put that cable or changed that connection and so on.
All right, so after building the network, when it's in an operational stage, of course, your data, the mobile mapping data that you have captured and documented, is of course very useful still in that operational stage. So, for example, during interventions, if you're being notified of a cable break or a network fault, this data can be used to see the situation on the field and be prepared for the field crew that needs to go out and make fix the network or the fault that was in place. Also, when new public works are being planned and you're being notified, you can immediately see the situation and react accordingly. We'll go into a particular demo on the analysis capabilities that you have using this mobile mapping data. Loma will explain further. But one other point that I want to make is that you documented mobile mapping data, all the information that you have on the 3D information that you have about the buildings can be used for your mobile network planning as well. So for determining location of new 4G mobile sites or 5G small cell locations, this data can be used for this analysis to determine where you want to place new antenna site locations. And of course, these new antenna site locations can also be connected with fiber using our solution. But we'll go into an example where you can use the automated analysis functionality of Orbit.
Well, indeed. Of course, what we explained during the presentation was what can you do with mobile mapping, and then focusing in fact on the imagery. And we just used the point cloud as a resource just to measure, because this represents the XYZ of a pixel of the picture. And of course, you can use that to do all kind of actions during the process of an FTTx project. But it goes further. I mean, thanks to the fact that you have a point cloud data. Thanks to the fact that you have that scan of the environment, we have a very rich database that we can use to do all kinds of analysis, and that goes a lot further, of course, than just measuring. And I just want to give two examples right here, because I'm quite sure that that you have a lot of ideas what you can do with point clouds, and there are a lot of tools into the software. I just want to stress two. One is a very important and used a lot is based on the clash detection tool that we have in our product, and that's, for instance, to check how close vegetation comes to a cable. So what you can do is you can define a certain shape. That can be a circle, that can be a square, any kind of shape. And you can maybe put as well a kind of buffer zone around it. And then you can run over the point cloud to detect where, or you run over a path, and that path is in this case the cable. You run over that path and you detect where that shape will clash with the point cloud. So you see the hits, in fact, where you have or you will have problems because vegetation is too close, or maybe within 1 year or within 2 years there will be a problem over there. So it's making an analysis of the existing situation as it is, and checking where vegetation comes too close to cables, to objects, to any kind of an important situation or location where there will be problems. And of course, you can report that. You can put that easily in a document. You can group all those clusters and then, of course, report that to the teams that needs to solve the issue. Now, a second thing of example I want to give about 3D analysis is a nice example of one of our customers that created that, and it's all about line of sight. It's to detect where are the best positions. Where do I have a connection between two positions or two locations? Do I need to choose for a fiber cable underground, or can I just go for a network above ground? So all checking that and making that analysis can be done, of course, using the point cloud data, because the point cloud data gives that complete environment, and you can just put some algorithms on top of that and just let the computer do the work and check exactly where the best position would be. Or, of course, based on the information you already have, you will have already some locations where there are spots or where there are points that you need to start from, and based on that, you can go one step further to check what is the best position then, starting from here and creating my network. This is now in the line of or in the view of line of sight, of course, to connect two positions without any object in between. There's no tree in between. There's no building in between. At least you can use the point cloud for doing that.
All right, so we've reached the end of this webinar almost. Some points that we wanted to make during this this webinar are lined up here. So yeah, what we wanted to show in this webinar is the real advantage of using mobile mapping in your FTTx project. I think what was clear is that it's definitely a way to save time, to reduce the amount of field visits and the time that you need to spend during a field visit, because you can already do a lot from behind the desktop. Also, an important point is you avoid mistakes. You can really centralize the decisions instead of letting the people in the field making the decision on their own. You can take that power back a bit and centralize the decision so that you have a uniform or a consistent way of building the network. Then with mobile mapping, you can assure that you have quality input data, which allows you to benefit from the cost and time savings of automated planning and design. So due to that integration between Orbit software solutions and the FiberPlanIT software solutions. And at the end, we also wanted to show you that with mobile mapping, you get a lot of information about the state of your network, so that completeness of the documentation can be used in a lot of different ways during the operational phase or network expansions, and that's a huge advantage. All right, so here we see the two software solutions next to each other. So we have the Orbit software solutions on top, where you have the content manager, where you can manage all of the data that you have captured through mobile mapping. Then there's also the solution to do the modeling, the feature extraction, using your mobile mapping data to acquire the GIS data and work with your data. Of course, you can publish it to different platforms wherever it may be needed. And at the bottom, we see the FiberPlanIT solution. So we have the simulator for strategic planning purposes, and the designer for high-level design. And then we have the FiberPlanIT engineer for doing the low-level design. Now, how do these two solutions work together? Well, they use the GIS data as a common exchange format. The best example that I can give, and which I showed in the FTTx project workflow, is that design and survey go hand in hand. So the FiberPlanIT designer uses GIS data, which can be enhanced with mobile mapping data. With the Orbit solution, you can have enhanced GIS data. And the outcome of your design is again GIS data that can be fed into the Orbit platform, so that you can make the necessary changes and then automatically rerun your design, fine-tune it with the FiberPlanIT designer, so that you get an updated design which is feasible and constructible. Okay, so we've reached the end of this webinar. We're right on time, I see. If you have some questions, throughout this webinar, feel free to ask them via the GoToWebinar Q&A window. Let me check if I have a question here. Yeah, this is an interesting question. Question is, what is the added value compared to Google Street View? And I think that that's really one of the points that we wanted to make during this webinar. And I'll let Lomme explain in a bit more detail and answer that question.
Yeah, I guess there are, thanks for the question. There are, of course, many ways why doing it yourself, or at least not relying on Google Street View, is an advantage for the for your own project. First of all, of course, you know exactly the date when you captured the data, or when your data provider captured the data. So you know exactly the date, the timing of that image, which is a first very important point. Second, blurring. There are no buildings blurred, of course, which can be, of course, the case in Google Street View. Next to that, it's all in your own hands when you will do a new collection of data, or what data we will use. Another point that we stressed, I guess, is the point cloud, of course, to measure. I mean, the easy way to have that point cloud, not only for all these analysis, but as well to measure and to, in an easy way, add information, update your information, is of course a huge difference than using a resource which is provided for daily use or commercial use, instead, of course, of this data that you can capture by your own, or that you can get from data which is already available in your country or in your city, or from companies that wants to collect the data. Yeah.
Okay. Thank you, Lomme, for that answer. I think we've reached the end of this webinar. Any other questions that came in, we'll answer via email. If you have some questions after the webinar, feel free to contact us through email. Our email addresses are on this slide. And yeah, so later this week, we'll send out a link to the recording of this session. Thank you for joining, and have a good day.